Hello, momentum, change in momentum, impulse, and the speed skater. Make sure you have your calculator with you. Prove each page and try to stay ahead as best you can before the end of the movie. If you have any questions, again, please write them down or comment me on YouTube, and I will try to answer your questions as quickly as I can. The best way to do it is, of course, bring your questions to class and ask me then. Thank you very much. Have a good day. Enjoy the movie, and goodbye. Jason, a 100-kilogram speed skater, is skating in a race a constant speed of 25 meters per second when he hits a rough patch of ice with a coefficient of friction of 0.05. How long will it take before Jason coasts to a stop? Listed below are 6 equations and the data table containing the knowns and the unknowns relative to the problem. He is 100 kilograms. His velocity is 25 meters per second. The coefficient of friction is 0.05. We need to calculate his weight, the normal force, which would be equal to the weight, the coefficient of friction, which would be the product of the coefficient of friction times the normal weight, and the momentum that he has before he hits the patch of ice, and then the time needed to stop. The 6 equations are listed on the left, and it will be linear. It will not be on a ramp. It'll be linear, so the weight will equal the normal force. Good luck, and let's see how you do. The problem is broken down into 7 steps. A is the calculation of his momentum. That'll be 2,500 kilogram meters per second. Now, this will be the momentum that will actually change. When he's going 25 meters per second, his momentum will be 2,500 kilogram meters per second. He'll hit the patch of ice, he'll come to a stop, and he'll lose 2,500 kilogram meters per second. Now, that will equal the impulse. His weight is 1,000 newtons. Because it's horizontal, the weight will equal the normal, so that will also equal 1,000. The friction will be equal to mu Fn, which would be 50 newtons. Now, this is also the net force that actually brings him to the stop. We'll just call it FF for now, but that's the actual net force that he needs to lose, that he will lose when he comes to a stop. That's actually going to stop him. And you could actually call that the net force. Now, the change in momentum will equal this net force or friction times the time. And then rearranging the equation, delta T equals the change in momentum over the friction, and that will equal 50 seconds. Now, make sure you understand that the force of friction is actually the net force that will stop him. If I slide a playing card across a table and I'm not touching it anymore, the card will stop as a result of the net force that's actually going to bring it to a stop. In other words, that card would continue at a constant velocity if an outside force didn't act upon that, and that outside force is the net force, or the friction. So, if you don't understand that the frictional force is actually the net force, ask me specifically, because that's going to become very important even in this chapter and the next chapter. You have to understand, in this particular sense, why the force of friction will actually be the net force that stops the skater. Listed here is a free body diagram with a calculation, specifically as to why the net force will equal the friction. Fp is 0, and the net force is the sum of Fp and Ff, and if Fp is 0, then Fnet equals the friction. The only vector specifically, the only force vector specifically acting on the skater is FF. Therefore, the impulse has to be FF and the time in which the FF is being applied. Therefore, the change in momentum will equal the force of friction that's being applied over a certain period of time to stop the skater from moving. As I throw a card across the table, that card will be brought to a stop by the friction. So the friction is the net force that will be applied over a particular period of time in order for the velocity to change or the momentum to change. The final slide is the completed data table, where the time, that's specifically what I was looking for, as it says, how long will it take before Jason coasts to a stop. So the answer is 50 seconds. Have a great day. If you have any questions, write them down and see me in class. Thank you.